Hey everybody, welcome back to the shop. I'm working on this job here that landed in my lap first thing this morning. It's something that I needed to jump on right away and try to get these guys knocked out. It's another job that we're doing for the welding shop. So what we have are 34 pieces of 2-inch cold rolled. Now these here are your 1018 cold rolled, I believe that is too. These right here are actually turn, grind, and polish. That's probably 1045 steel. But they had this over there that they could use to complete the order there without having to order a whole nother bar, another length of bar stock there. So they're using this turn, ground, and polished. I didn't even know he had that over there, but it's probably something that's been on the shelf for a long time. So anyway, I'm going to be using our Milltronic CNC mill to get this done. And I've got 2 vices set up, so we have 2 different work locations. We can set up 2 pieces of bar stock, get the holes drilled. It takes, I think, about 3 minutes to get it done. I've been kind of tweaking the program a little bit, trying to improve it a little bit. After these 4, I think I got it to where I'm just going to leave it for now and just let it run, because it's going to go through these parts here pretty quickly. So I am using a high-speed steel drill bit to get this done, and the reason why is because these need to be done pretty quickly. I need to get them back, end of the day tomorrow. I need to get them back to them. So instead of ordering a solid carbide drill or a carbide tip drill that we can use that might take a couple of days to get in, I'm just using what I have right now, which is good old high-speed steel drill. I got a couple of those, so if the drill happens to start getting dull, all I got to do is touch it up and just keep on going. But it's doing really good with these. I've got it flooded with coolant, and we're running good speed for mild steel, and I think it's going to be just fine. So, like I said, we are going to be using the Milltronics, the TRM 3016, to get this done. And everything's working pretty good. So I used Fusion 360 to create a program to get this done, which is helpful. Every time I get a job or a project like that, we jump over there in Fusion, and I get with Kevin over at Mechanical Advantage, and he coaches me through it and helps me write a program. And every time I do that, I understand a little bit more and a little bit more understanding of that each and every time we do that. So thank you, Kevin, for helping me with this. I really appreciate it. We actually have a couple things that we could probably improve, but I've been trying to do that on my own as over there, and I run a couple of them and see what's going on. The movements of the tools isn't ideal, but since we're just drilling the 4 holes and it's got fast rapids, I don't really think it's a big deal. So we're probably just gonna just get through this. I do have a little bit of video of the setup for the 2 workstations there. So we'll go ahead and share that with you, and then we'll go ahead and jump over on the machine and start getting these guys drilled. So we just found the work location for G54, which is going to be this vise here. We're going to do the same thing for this vise. It'll be G55, just so that we can run identical parts, just in 2 different work locations. So we'll do the same thing over here with our probe. Find the center. So what I've been doing is just find the center of it this way, find the center of the workpiece, which is 10 inches long, and our Z0, which is our work surface, is going to be off the top of the material there. I hate to say it, but I did it. I was trying not to, but I just broke the ruby on the end of the Renishaw probe there. It's easy to do when you get in a hurry. I had it in Z. And I thought I had it in X, and I reached up here to crank the hand wheel, and it just went down and hit the ruby. So that's unfortunate, because that's what I've been using to locate our work offset. So I'm gonna have to go see if I can get another one of these guys ordered for the Renishaw, and we'll just have to do this a different way. So I'm having to set the work coordinates manually now. This is just sitting in there so I could hold my pointer. I use my rule to find the center of the workpiece and zero it out that way. So I'll go ahead and let you know. I went ahead and jumped on the Renishaw website. I got 2 of these ruby tip styluses ordered, and they're not cheap. This particular model that I have is $97 a piece. I went ahead and ordered 2 of them so that I would have a backup for when that happens again. I'm sure it'll happen again one day. I'd rather have one here and not having to be waiting on it. So that was very unfortunate that happened, and that's easily what happens when you're standing here moving the machine around and you reach up here to do the hand wheel and you see where the XYZ is. Sometimes I reach up here and go to push it, but sometimes I don't actually get the key that I'm looking for because I'm not paying attention to it, and that's what happened. I came up here and tapped it, and I don't know what it was, but it didn't change or something. I don't know exactly. I just tell you it was in Z, and I was getting ready to move it down, and I hit the hand wheel, and it just brought it down into the workpiece and shattered it. So hopefully everything else is fine. Whenever I get it in, I'll see about going through the procedure of replacing that stylie in there. So I had to get the old book out, go through here and read and remind myself how to set a work coordinate over here manually. It's pretty simple. Go to the F7 key, I'm sorry, the F10 key right here to select which work coordinate that you're working on that you want to set. Right now we're in G55. That's going to be G55. And you just simply come in here to this F7 key once you have it positioned where you want to. And no, we're not going to do that. Let's see, abort. X. That's what we're looking for. G55X. X position. So we want it in the middle. 0. There we go. Now I had already found Y. So that's already in the center. That's already good. So I'm going to have to take my tool. I'm just going to take the drill bit and come down here and just barely touch the top of the workpiece and then zero it out that way. Just use the paper trick down there. I'm not going to be running the spindle, and I've got the wrap its way down. Just bring the Z down nice and slow until it stops on the paper, just like that. That's going to be our Z0. All right, so we're in Z, G55Z. 0. All right, we should be good to go there on our work coordinate for G55. Okay, I think we are ready to go ahead and start our program and see if we're gonna make some chips successfully. Well, I got the first 2 drilled. Everything went fine. There's some refinements that I need to do in the program itself. My PEX cycle isn't working the way that I'm wanting it to. I had it set to where once it goes down, I think it was 3/4 or halfway down, I need to check it. It actually starts retracting it at that point to pull the chips out. Well, it retracts and comes back in, and then only does the break as it goes down, and as it gets near the bottom, it retracts out to clear the chips and comes back in. So I've done something wrong in the program. I need to go jump in there and see if I can figure that out. I might have to give Kevin a call and see if that's something that he can help me with. Not sure, just got to go play with it and see. But that 3/4 inch high-speed steel drill bit is actually working pretty good. We've got I think we got our speed and feed set pretty good on that, like you would usually use on a manual mill. And I've already measured them and confirmed they're on the right center distance, 8 1/4 inches from center to center for the holes. And they're just being used as some kind of pin. You know, they stick them in something, they throw a bolt through there to capture it, and I believe that's that's how they use them. So we'll clean this up. I'm going to see if I can work on the program a little bit to kind of optimize the cycle here, and we'll show you some machining once I get that figured out. I was going to point out, I'm going to go ahead and finish all of the cold rolled pieces up to this point right here, and when we jump over to these shinier pins, I'm going to change the RPM and the feed rate a little bit because this is a little bit tougher than mild steel. So I'd like to get through all the soft gummy stuff with our good drill bit before we go into this, and we'll just drill these last. Okay, let's get a couple more loaded up. It's as simple as setting them in there and sliding them over against the work stop. As easy as that, and then we can hit cycle start. Let's give our spindle mount a try, see if you can get a good video from there. I am using a lot of flood coolant, so that may kind of hinder the video, but we'll see what we can get for you. So this first drill, it's a mill drill that I'm just using to spot the 4 drill locations. And then we'll switch back to our 3/4 drill bit. So the speed at which we're running the drill bit is 458 RPM. That's based on 90 surface feet a minute. And our feed rate, I've got it set to 5 inches a minute for the feed rate. That's going to be right around, I believe it was around 10 thousandths per revolution. Forgive me if I'm wrong on that. So we have it pecking so that it'll break the chip, so we're not making helicopters, and I've got it set at every 5/8 it actually comes out to clear the chips. And now we're moved over to G55. The order in which it's drilling the holes is what I know that could be improved. I played around with it trying to perfect that, but I didn't want to pose a risk of screwing something up really bad, so I just held off and just left it where it was at. And we're just going to let it run through the job. I'm going to see if I can get Kevin to help me look at the program to see if we can tweak it to correct that, because you can preserve the order in which to drill these holes. And I thought I had it set, but evidently I don't. That's part of my learning process. But you can see the good old classic high-speed steel reduced shank drill bit is what we're using, and it's doing a good job. Keeping that flood coolant on it, it's pulling off a good-looking chip, and I think it's going to work fine for drilling all these holes. And that's it. So a total of 3 minutes and 3 seconds per cycle. So about 1.5 minutes each is what we're at on drilling the holes here. So we'll go ahead, and all I've been doing, I'm trying not to clean it too much, but I take a brush and just try to brush these chips off, the rough chips. Get them off out of the way. I want to blow the fine chips off from behind here. And then we'll loosen up the 2 vices. Start with the right side, then I move over to the left. All right, then we'll take them out. Rinse and repeat. And we go back to load 2 more. You can just take your brush and make sure there's nothing just sitting down there at the bottom. Nothing too critical on these guys. There's a lot of clearance everywhere you look on these pins, which is real typical in this kind of work. All right, I'm going to tighten up the one on the left side, and then we'll come over here and tighten the one on the right side. We're ready to hit it again. Cycle start. So the first thing I thought about whenever this job landed in my lap this morning was how many thousands of holes I have had to drill in my career using a manual milling machine, one at a time. And also how nice it is to be able to take your CNC mill and make a simple program and let it drill these holes so that you don't have to have that big arm workout all day long. Now, if it didn't have the CNC, that's how I would do it. I'd continue to do that, but I'm making use of the machine that I have at my disposal here to get these done quickly and more efficiently, honestly. But absolutely nothing wrong with doing these manually in the mill. That's how people all across this country do this kind of work every day. That's how I've done it my whole career. I'm just really excited about using this newer machine to be able to get these jobs done so much more faster and simpler, for me anyway. This Milltronics TRM has been an awesome milling machine. I've had no issues with it whatsoever, besides the things that I do wrong, like break a ruby on a Renishaw probe, but that's not the machine's fault, that was my fault. But I absolutely love this machine. It's been working great. It's been a perfect beginner CNC mill, I gotta say. Plenty of work envelope. Got the full enclosure so we're not splashing coolant all over the shop or chips. I think it's been a great machine to learn how to do this work on, and I'm excited about maybe make an investment with a more advanced machine later down the road in the future. So on that drilling cycle, the way that I got that, or the program that I selected is a PEX cycle, but after it reaches a certain depth, I've got it set at 5/8, so 0.625 inches. Once it hits 0.625, it retracts fully to clear the chips, and then it keeps going. The PEX is set at every 3/16 of an inch, or 0.1875 is when it does the break, the chip break. And then we hit 5/8, it'll retract and clear the chips right there. There it is. 3 minutes and 3 seconds exactly, just like the others. So we got this dialed in working pretty good, and we should be able to get through all these 34 pieces pretty quickly now. I modified the first tool to not use coolant. Let's see if that helps out any, at least with our video at the beginning. I don't think we necessarily need coolant on that. I know that it's good to have it, but we're trying to keep from splashing it all over the camera there. Going 100,000 steep with that. It's running 5,000 RPM. All right, 2 more parts loaded up. Let's give you a shot from the outside here. This one we'll have to use our door to kind of shield us from some of that coolant there. Three minutes and 3 seconds. Being pretty consistent here. All right, guys, I'm just gonna keep slamming through these parts and getting them drilled. I think you'll have seen enough machining. We got some nice chip making in the action right there. Just some good looking chips off of a regular old high-speed steel jobber drill there. Okay, I just hit cycle start on 2 more. I'm gonna go ahead and start deburring some of these guys. We'll see how many we can get deburred while 2 of them are being drilled. So we're just gonna use the good old trusty Noga tool, I hope. Let's see if it'll, oh yeah, it'll cut that burr off there. Just a very simple deburr. All right, there's one. Might have to give you a different angle. I think I'm blocking the view of the camera there, aren't I? Still drilling. Let's go ahead and get another one in. All right, I just finished up the drilling. Finish this one here, and I'll go load 2 more. I don't know, I didn't even count how many. 1, 2, 3, 4, 5, 6. It's either 7 or 8 that I have deburred while the machine's drilling. It's the next day. I'm down to my last 6 pieces that we got to drill. Should go pretty quick. So we just got the machine fired up and homed, and we need to turn on our Kaiser, get some good air coming to the machine. Go ahead and turn that sucker on. It's flashing here, notifying we had a power outage, and it shut off during that power outage, and it's also due for its service. So we're going to get that done pretty soon. Kaiser has been fantastic. I haven't had any issues with that, and it surely does provide awesome clean air for our machines here, for both the Miltronics and the Flex there. We'll let that get pumped up. So we're down to our turn, ground, and polish pieces there. I'm pretty sure this is going to be 1045. I think what I'm going to do is jump on Fusion and go ahead and look at the recommended surface speeds for medium steel, and maybe make an adjustment on our RPM there while we cut these. I brought you guys in here with me to the computer. So here's a look at Fusion and our setup for drilling these 2-inch pins. So first drill is going to be the spot drill. So we're going to go to drill 2. This guy right here, we're going to edit it. And then right here, we got our surface speed set to 90 feet per minute. And the feed rate is at 10 thousandths per revolution. I think we'll leave that alone. So spindle speed, 458.3 RPM. Let's go ahead and just highlight the 90. Let's go with 80. That's going to drop it down to 407 RPM. We'll leave the feed rate where it is and hit OK. That'll change that. And then we'll come up here to NC program, right click, hit post-process, and it's going to overwrite the previous program that I already did right there. So hit yes, and there it is. It is ready to go. It's over here on this side. It's not letting me bring it over here. Anyway, that was a G-code. It threw it over here on my other screen. So just a simple way to make a modification there. Thought I would show you guys that. So we'll go ahead and go load that back into the Miltronics now. Okay, we're drilling our turn, ground, and polish pins. Seems to be doing just fine. I was trying to play it safe and lower that RPM just a little bit. The chips are looking good. They're looking consistent with the 1018 material as well. Yep, everything's looking good. So we'll get these last 6 drilled and this will be done. Okay, everything is looking good. No problem with the drill. On our program, looks like we added another 25 seconds by slowing it down that little bit there. Doing really good. All right, so we got, I don't know, 4 more of these to drill and this job will be finished up. So on to the most exciting part of the job, cleanup. It's always important you clean your machine, get it ready for the next job. You don't want to do this whenever you're trying to get over here and set something up. So occasionally we get people that ask questions about, cleanup and how do you keep the machine so clean, or what do you do? So I just thought I would put a little segment in here and talk about this. So first thing we're going to start with is chip removal, obviously. I'm going to go ahead and, I purposely did not sweep these off during the job so that I could do this right here. Try to collect as many as I can up high, and less chips down in the actual chip pan because I got to clean that out anyway. So just go ahead and get the chips cleaned off first. I'm just using these plastic brushes here. I get these from McMaster-Carr, and I try to keep them at every machine. So we'll get the chips off here, and then I'll show you how I'd clean the table after that. I got these chips going into a clean trash can here, and typically what I do, is I just walk over to Joe's scrap bin. He's got one of those big roll-offs, and I just dump these chips over there in his scrap bin, because I don't really have enough to justify trying to keep some kind of scrap bin around here for chips. I just really don't feel like dealing with it. And on occasion, I get to kind of pilfer through Joe's drop pile over there and get me some materials that I need. So I think either way, it's kind of a win for me. Try to be real careful around that Renishaw probe. Tool setter. It's actually a tool setter, not the probe. Get them all off the table. I brush them off of these chip guards here as well. I try to keep those as clean as I can. And that's where these brushes work really good, where all these old wiper seals are. Get in there and try to wipe all the fine dust off of those and help kind of prolong the life of those and minimize the scratches that you get in those guards there. I like to try to get in here behind it too and get the bulk of these chips off this chip guard here. I do have a spray nozzle and I use that frequently as well, but right now I'm just using the brush. Still got a few more back here too. Got most of the chips off there. I do come in here with some air and try to blow a little bit more off the vices here, like out of the inside the cavity. Just trying to get them out of the vise. All right, now that I got it to this point here, we'll go ahead and blow it off with the coolant. So we have a wash down nozzle there, so we'll go ahead and activate flood coolant. First thing you want to do is shut these guys off before you activate flood coolant. All right, and then hit flood coolant like this. Now I've got the tip unscrewed from that because it's a pretty fine tip, and this kind of blows it out a little bit more, as you can see, like that. So this is where it can get a little messy, so you got to be a little careful on how you're spraying the coolant out, because it'll try to come right back up on you and make a mess. But so we just go through here like so and just rinse everything down. Try to blow all the chips off, all the fine chips. We'll come through here as well, and I'll blow all of these chip guards off. Try to wash any of the fine chips out of those chip wipers. Same thing with the front and the back down here. Just like this. You can go around the machine and wash it all down, get it off the back right there. All right, so let me finish getting this clean and I'll bring you back for the final step once we're through washing it down. All right, so once we get it down to this phase here, we've got most all the chips washed away. We've washed all of the chip cards there, and I'll just take this air nozzle here and just try to get some of the coolant off. Just trying to get most of it off the table and the vices right here. Grab a couple of our pig wipes right here, like so. And then come in here and just kind of mop up a little bit of the extra coolant. Try to get the extra off of the table and off the vices, about like that. Just keep working it and just kind of mopping up what's left of that coolant on the table and the vices here. After I clean the top of the table with the rag, I like to come in here and just kind of wipe off these way wipers here. or the guards, but these wipers in between each guard. Just kind of give those a wipe and make sure there's no chip buildup. We haven't been doing anything fine chippy over here, just drilling holes, but you know, other jobs where you're making a lot of fine chips, like when I did that cast iron, I came in here and cleaned this really thorough to make sure there was no dust and fine chips caught in all these way wipers here. So that's just another step I like to do in here on the Miltronics. And we'll move her down, and I'll do the same thing over here on this side as well. Just wipe those, just give those seals, or I'm sorry, the wipers a good wiping of the rag there. Now let's just make sure there's nothing left on there for it to scratch. All right, do the same thing down here, and then I'll do those on the back and those wipers right there too. Okay, last step of the cleanup. I use my CRC SP350 and coat everything down right here. This is really good stuff. It's going to provide rust inhibitors on here. It's going to keep everything lubricated, and it's going to create a nice film of oil on top of everything that'll keep it protected for a long period of time. But this is a good preventative maintenance right here. Just come in here and just give everything a nice coating with our SP350, just like that. That will also help extract the water that's in the coolant there. It'll make it float to the top and evaporate and create a nice little surface underneath it, protect it with oil. So this is what I like using on the machines, on all my bare metal. I want to keep it protected. I'll even spray it up here, you know, on the spindle, because those are bare metal as well. So that's my cleanup right there. And now it's ready for the next job. Here's a little closer look at our drill bit that we used for this job right here, drilling all these holes. All right, so it is a Chicago Latrobe, 3/4 inch, high-speed steel. This goes into my drill index. I have this from 1/2 inch up to 1 inch in 64th increments. So before we started this was a used drill. It wasn't brand spanking new, so I've used it a few times. And you can see that you've got a little bit of wear. There's a little chip right there. And on this other side, you've got a little chip right there as well. But it's got normal wear, but it's still doing a really good job and would have continued to drill, I'm sure, many more holes in this mild steel. So anyway, I just wanted to show you the cutter that we used for this entire job. It worked out pretty good. This job is now completed. All the pins are drilled. We've got them all deburred using our Noga deburring tool. We're ready to load these guys up and take them over to the welding shop. Our Miltronics TRM 3016 did a fantastic job at this job right here. I was really happy to be able to use a little bit of automation versus having to use the old manual mill and pulling on that quill there. But if I didn't have the CNC, that's where I would have done them, right there in the KBC mill. So it worked out pretty good. As far as the time that I got in this job, so keep in mind, I'm continuing to try to learn. I'm learning how to do CNC, and I'm learning how to program using Fusion 360. So I would approximate between making the program and setting up the mill, I've got maybe 1.5 hours and 2 hours total in all of that. Each one of these, well, let's see, these guys right here took 3 minutes. These took 3.5 minutes. I just kind of figured 5 minutes total between setting them in the machine, pulling 2 out, setting 2 back in the machine, hitting cycle start. We probably got, let's just call it 5 minutes per pair of pins right there. So that's going to be somewhere in the 1.5 hour range. Let's just round it up to 2 hours for doing all this. So I've got approximately 4 hours total in all of this work right here over on the CNC. So programming it, making a program, setting up the vices, getting them trimmed, setting our work locations, breaking a ruby on the Renishaw, which I'm not proud of, and then getting all the holes drilled, deburred, and now it's done. And then I think about things like this. I still have to handle these again. I need to load them up, take them to the welding shop, unload them. You got a little bit of labor in that as well. And I took a little bit of time to kind of wipe all that grease and stuff off of them. So I'm just going to say about 4 hours in the job right there, okay? But that's it. We're going to wrap this up. I hope you guys enjoyed watching this this little job get done, and we'll bring you guys back. I got some more projects lined up. We got some more stuff to do in the Flex CNC. I got a big cart top to machine over there, and I have some repair jobs lined up that we're going to be doing here pretty soon there as well. All right, see you guys later.